All right, in this video, we're going to continue our conversation on banking, and we are going to be focusing on compound interest. While we're discussing compound interest, we're actually going to bring in a couple of formulas that we'll have to work with. So it would be the compound interest formula as well as the compound continuously formula. All right. So first off, what we have here are a couple numbers here that work with uh, some words that should be very familiar. Okay, so just take a second and take a look at that. Now remember, again, well, I haven't said it yet, but you're gonna be dealing with questions that deal with these words, and you need to know, okay, like for example, daily. All right, so if the question says blah 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 daily, I know that I'm going to have to use 365. Okay, if a problem, let's say, dealt with compound interest compounding monthly, then you know that 12 is going to be used somewhere in the formula. Okay. Now, compound interest is money that you earn when you invest an initial principal. Now, remember, principal means the amount of money you start off with. All right, so what I'm going to do here, I'm going to do a quick little demonstration, and I'm going to try to make you guys visually see what exactly is going on. That's month 5. All right, so let's say, for example, we started off month 1 with $1,000. Okay, we invested $1,000 in a bank account that draws interest monthly. All right, now I'm just going to play with some numbers here. A lot of these numbers aren't going to necessarily make sense, but we're just going to play with them just so you can get an idea. So in 1 month, I was able to earn $5 in interest. Okay, so that means if I was to leave this money in the account and not even touch it, that means in month 2, I would now have 1,005. Okay? So notice how my money has grown. So if I leave it in another 30 days, and let's say it adds $6 in interest. Okay. So we're going to take this amount of money and then we're going to go to month 3. And now we're going to end up with 1,011. And then let's say, again, I'm just playing with numbers to make life a little friendly. Let's say every month I'm getting more and more interest. All right. So what compound interest is basically it's money that you earn on top of the money that you've already earned. Okay. Now that may not be the best way to explain it, but it's the best way I got at this moment. All right, so that would be 118, and then let's say I ended up drawing 8, and then just so on and so forth. So the pattern just keeps on going. So basically what it is, it's money that you earn on top of other money. Because the thing is, remember, I started off with $1,000, and I kept on adding all the interest, and now after 4 months, I was able to make 18 or $28. So that's basically how compound interest works. All right. Now, the formulas that we're going to run into look like this. All right. So the compound interest formula, compound continuously formula. All right. So these are the ones that we're going to need to know. It's relatively simple. The one thing that I will say is a dead giveaway with the compound continuously formula is when you see the word continuously. When you see the word continuously, that means you're going to use this formula. All right. So let's get started. All right, so answer the following questions. All right, so Jimmy invests $4,000 in an account that pays annual interest compounded. Oh, here we go. Semi-annually. Okay. Now, pause for a second. Let's go back to our formulas. All right. First off, the problem did not say anything about continuously, so I know that's not going to work. Okay, so it's going to be this guy. The reason why, and let me go back. The reason why I underlined and now boxing semi-annually is because that is what we're going to need to use. All right, so let's go back to our numbers here. Semi-annually, look at that. That means 2. All right, so I'm going to use 2 in this formula. Now you might be asking, well, where would I be using it? That's where the n is. See right here? The n right here would be 2 in this problem. Okay, now I'm going to flip back and forth a little bit. I know it might be a little confusing, but hopefully you can stay with me. All right, so Jimmy invests $4,000. All right, so the principal would be 4,000. And then the R, I believe the R was 5%. Let's see, the R is 5%. So that means in my problem, the R, I'm going to do this in another color, would be 0.05. Okay. Now, before we get started with this formula, notice how the formula starts with B. Okay. Now, this is something you're going to have to remember. Whenever the formula starts with B, that means it's a balance, which means how much money is in the account. All right. Or in other words, it is the total money. Okay. If the problem ever starts with an I, that means interest earned. Okay. So notice that both these two formulas that we're running into starts with B. So that means when you press enter, it gives you the total money. Okay. So in this particular problem, now what I'm going to do is I'm going to type it the way I would type it into a calculator. All right. It just makes life easy. So 4,000 parenthesis 1 plus 0.05 divided by semi-annually 2 close parenthesis. All right. Raised to the power of 10 years times 2. Oop, times 2. Close parenthesis. Okay, so I would type that in just like it would. All right, now of course, I forgot about the 10 years. The 10 years would be time, which is right there, that T right there. All right, so when I press enter, remember, it's going to give me the balance. All right, so first off, let's answer a couple questions. All right, how much was Jimmy starting out with? All right, well, that was easy. It gave us to us in the problem. It was 4,000. All right. Next, how much will Jimmy have at the end of 10 years? Okay, so this right here represents, they're asking us for the total money, which is the balance. So I'm going to go ahead and plug this into my calculator as it is written and type it and press enter. So when I do, I get $6,554.47. Okay. Now, how much interest will Jimmy earn? Now, remember, interest means money made. So let me write that off to the side here. All right. So interest means money made. All right. So think about it. He started off with $4,000. All right. So he started off with $4,000. And now he has $6,554. How much money did he make? Well, simple subtraction problem is going to help us out. So 6,554.47 minus 4,000. When you do the math, you get $2,554.47. That's how much money he earned. All right. Next question. On Olga's 16th birthday, her uncle invested $2,000 in an account that was locked into a 4.5. All right. Oh, here we go. I just see it. Word association. Continuously. Okay. So going back to my formulas, I know that I'm going to use this formula down here. Okay. So that word continuously trumps everything and says, okay, we're going to use this guy. All right. So, and I'm just going to put it right over here. So B is equal to PE, and I can RT, I can. It's also known as the PERC formula, I think. All right, there we go. All right, so first off, how much money? Okay, so Olga started with 2,000, so that's what's going to be the P is 2,000. Okay, the R is going to be the interest rate written as a decimal, 0.475. All right, so the time might be a little confusing, but if you look at it, it shouldn't be too bad. So if you notice, the problem started on her 16th birthday and it ended on her 18th birthday. So the answer is going, or the time will be 2 years. Okay. Now, the last thing is, well, what does this E stand for? This E stands for the function that is on your calculator. Okay, so if you have a graphing calculator, you should see where the E function is. In fact, I'll give you a picture of it right now. All right, so this is a picture of a TI-84. All right, so the E function is right there. See where that ln is right there? Let's see. Oh, okay, there I do it. All right, so stop moving. All right, see where this ln function is? See that little e exponent? That's what you're going to use, okay? So you are going to hit the second key and the e key, or the second and the ln key to activate the e, okay? So All I'm doing is explaining you how to work it. If you want to know what that E stands for, watch another video. Okay. So in the calculator, all right. So I'm going to type it in just like it's going to be written. So 2000 E, and usually you probably have to use the caret function on the calculator. All right. 0.0475 times 2. All right. So when you do that, that's going to be, oh, forgot these little questions again. How many years will Olga's money be invested? 2. All right. So how much money will Olga be when she turns 18? Remember that this formula starts with a B. That's our balance. That gives us how much money will be in their total. All right. So that $2,199.31. How much interest will Olga earn? Remember, interest represents money made. She started with $2,000, and now she's at $2,199.31. So again, how much money did she make? Well, simple subtraction problem is going to help us out with that one. Minus 2,000. All right, so my answer is $199.31. All right. All right. So for this question, it's very straightforward. Samantha deposits 1,500. Okay. Da, da, da. All right. Well, word association. They're using the word daily. Well, the reason why they're using the word daily is because this formula that we're going to use, notice it didn't say compounded, or it didn't say continuously. Sorry. Whenever it says daily or monthly, that means that is the number that's going to go in for n for this particular problem. All right. So for this problem here, I'm just going to go ahead and again type it the way I would in the problem. B is equal to 1,500 parenthesis 1 plus the percentage as its decimal divided by daily, which is 365, close parenthesis. We're going to need to do a caret because an exponent, 365 times 10 years. All right. So when you do the math, B ends up with $1,697.33. Now, here's where a lot of students are going to say, that's the answer, I move on. Notice what it's asking. It's asking how much interest did she earn. Remember, interest means how much money did she make. She started with 1,500. She ended up with $1,697.33. How much money did she make? Well, again, simple subtraction. She made, for my final answer, $197.33. All right. So, let's see. All right, I was just looking at the clock. I think we have time for one more. All right, so question number 5. How much more does $1,000 earn in 8 years compounded daily? Well, that one right there knows I'm going to use the big formula. Then $1,000 over 8 years continuously. Okay, well, let's see. We're going to have to do some work here. We're going to have to use two formulas because it says how much interest was earned compounded daily. All right, so let's go and do the daily question. All right, so that's going to be the really big formula. 1,000 parenthesis 1 plus my, there we go, my R as a decimal. Let's see, 365, that's right, daily, close parenthesis, raised to the power of 365 times how many years? 8 years, all right? So when I do that, the answer ends up being $2,491.78. All right. Well, let's do the continuously. I'll do the continuously way down here. Our continuously, B is equal to how much money? All right, 1,000. We're going to use the E. We're going to use the caret. Let's see, 5%, 0.05 times 8. All right. So when I do that, it ends up being $2,491.82. Okay, looks very similar. So, but here's the question again, be prepared. How much interest Remember, this formula gives us the balance. So very simple. We have to take how much money we have now, subtract how much money we started off with, and we get an answer of $1,491.78. Same thing for continuously. 2491.82 minus 1,000. That gives us $1,491.82. So what makes more money? Well, 4 cents compounded continuously does. So I think at this point in time, it doesn't look like really you're going to make out too much better other than 4 cents. So, but anyway, that's how you do it, folks. I'm not going to spend any more time going over it because those are the high points. As always, let me know if you have any questions. Thank you.